Today we are dealing with complex numbers, and they are all previous year questions 2023. So here z is equal to 1 plus I, z1 is equal to 1 plus I, z bar 1 minus z 1 plus z. So here you see that your one thing you see here, that is this is a very simple question. Just you have to place the value of z and z bar. Here you only knowledge that you must have what is z, z is this, and what is z bar, that is a conjugate. So this is the only concept, and here this is argument. The concept arguments means angle which the complex number makes with the x-axis. So this is the only concept. It's a simple question. Just you have to place the value of z and solve it. Nothing else. There is nothing any. Uh, it's a simple question. After all, this is a simple question. So I am going to put the value of z, that is z1 I, z bar, that is 1 minus I, and again z bar, that is 1 minus I, 1 minus z 1 plus I, and 1 plus 1 by z 1 plus I. Now just I have placed the value as per the normal rules. I have to just simplify, nothing else. So here I am going to rationalize it. 1 minus I am going to rationalize it. So here z1 is equal to 1 plus this will be I minus I square, and I minus I square, and here 1 minus I, 1 minus I, because 1 cancels out, and here again 1 minus I, and this is a square minus b square, that's I square minus I square, that is I square is equal to minus 1. So here this will be 2. Now again I am going to take here, this will be plus 1, so this will be 2 plus I, and here if we take the LCM it will be 2, and 2 will go to the numerator, and in the denominator it will be 2 1 minus I plus 1 minus I. Now I am going to solve this here. Here this will be z1 2 plus I into 2 by this is 2. So this will be 2 minus I plus I square and plus 1 minus I. Now again this will be z1 is equal to 2 bracket 2 plus I, and here this will be 2, this will be minus 1 minus I, and plus 1 minus I. So again minus 2, so z1 this will be 4 plus 2I, and here minus 2 plus 1, that means minus 1, and minus 2 minus 2I minus 1, that means minus 3I. Again I am going to rationalize it. So this will become z1 is equal to 4 plus 2I by minus common 1 plus 3I, 1 minus 3I, and here again 1 minus 3I. So in the numerator it will be common multiplication, that will be 4 minus 12I plus 2I minus 6I square, and in the denominator it will be 1 bracket 1 minus 3I square 9 I square minus I square plus 1, that will be plus 9. So here Z1, this will be plus 6, 10 minus 10I by 10. So this comes out to be minus 10. So this comes out to be minus 1 plus I. So when I have got Z1, so rest is very easy. So this was a very easy question, not so tough. Not so tough means it is a easy question. So you have to find out our argument. Your tan theta, that will be equal to 1 by minus 1, that will be equal to 1, that will be equal to pi by 4, but it lies in the second quadrant. So your argument of Z1, it will be second quadrant, so it will pi minus pi by 4, that is 3 pi by 4. This will be 3 pi by 4. Now you place the value here, 12 by pi into 3 pi by 4. So pi cancels out. 4 3s are. So your ultimate answer is 9. So this is a very easy question. So it's a very easy question, and only just you have to place the value of Z and simple solving. What is argument? Argument, that is the angle with which the complex number makes with the x-axis, and you find out the argument, you place the value of argument and solve it, so your answer comes out to be 9. Now my next question is, let the complex number Z is equal to x plus, this I is pronounced as iota, but I say I, that's all. It is I means iota. You will find in my lecture that most of the, instead of iota I say I. This is iota actually. Iota. Iota, this is iota actually. Iota, but I pronounce it as I for easy purpose, but it is I, x plus iota y. So here 2z minus 3 iota by 2z plus iota, and it is purely imaginary. See, this is purely imaginary, and this is given to you, x plus y square is equal to 0. This is given to you. Now you have to find out the value of this. So here what is z is given to you, 2z minus 3i by 2z plus I. This is, now you just place the value of z, nothing else. 2x plus iy, 3i by 2x plus iy plus I. This is all. So now you have to separate it, real parts and the imaginary parts. So here 2x plus I common, 2y minus 3. This is 2x I, 2y plus 1. Just you have to separate this, the real part and the imaginary part. So I common, 2y plus 1, and here 2x I, 2y minus 3. Now you have to rationalize it. So it is, but it is a simple question, only it is here, it is there. You have to work it out, and it is little bit lengthy. So here when you are going to rationalize it, so here 2x 2y minus 3 into 2x minus I 2y plus 1, and here this is 2x plus I means iota, remember this is iota, right? For convenience I speak as I, but this is iota, 2x minus iota 2y plus 1. For convenience I am speaking as I, but it is iota. So here you see that now you have to do, this is a multiplication, and here this is easy, but here this is a long multiplication. So you have to multiply because you have to separate the real part and the imaginary part. So here 4x minus I 2x 2y plus 1. Now here this will be plus I 2x, 2y minus 3, and this comes out to be minus I square, 2y minus 3, 2y plus 1, I square minus I square, and in the denominator it is uh, a square minus b square, so this is 4x square, and sorry, this will be 4x square, 4x square, and minus I square means plus, that is 2y plus 1 the whole square. Now what I am going to do here is that this is plus, so 4x square plus 2y minus 3, 2y plus 1, and here this is I 2x 2y minus 3 minus 2x 2y plus 1, this whole by I am separating it, plus 2y plus 1 the whole square, 4x plus 2y plus 1 the whole square. So since it is purely imaginary, so I am not at all interested in this real part is 0. So this becomes 4x square plus, you multiply it here, this comes out to be 4y square plus 2y minus 6y minus 3, and this will be equal to 0. So this comes out to be uh, uh, minus 3, okay, it is 0. So this is 4x square um, plus 4y square minus 4y equal to 3. Now from here we are going to get the value of x, that is minus y square. So minus y square square, this will be 4y to the power of 4. And here again plus 4y square minus 4, this is 4y square minus 4y is equal to 3. You take out the 4 common, so here your y to the power of 4 plus y square minus y is equal to 3 by 4. So you can see here you have to find out y to the power of 4 plus y square minus y. So here this is your answer. Remember that this x square, I have got this value from here, your x plus y square is equal to 1, so x is equal to minus y square. So x square will be equal to minus y square the whole square, so this will be y to the power of 4, which I have placed it here. So see, this is a simple question and the answer is 3 by 4. Now my next question is your PQ belongs to real number, and 1 minus root 3 iota to the power of 200 is equal to 2 to the power of 199 p plus iota q, and these are the roots of the equation. You have to find out the equations. You have to find out the equation. This is, you have to find out the equation. So here again you see that do not be nervous by seeing this power 200 or 2 to the power of 199. Never be nervous by 2 to the power of 199 p plus iota q. Use, never be nervous about it. Here the main concept is that a graduation level will enter into it while solving this question. A graduation level will enter into it while solving this question. So at that point, if you have no knowledge of this of the graduation level, then it will be little bit difficult for you, because there stage we come to a stage where your the 11 level, your that is +2 level, you can solve it to a certain extent by the +2 level, that is by your 11 concept. But after that you will require the concept of graduation level. So that is the critical point here. So now, but you be never be nervous with seeing the powers, power 200, power 199. So first of all, I'm going to do something making the same power. So first of all, 1 minus root 3i 200. So here I'm going to multiply 2 199 and divide it by p plus iota q by 2. So this becomes 2 to the power of 200. Now here I will bring it here, 1 minus root 3i by 2 to the power of 200 is equal to 2. This becomes 200. So the left is iota q by 2. This is left with you. Now this is the, and another step is that from here I will go to the polar form. I will go to the polar form. That is a plus ib is equal to r cos theta plus I sin theta. I will go to the polar form. So here you find that this is 1 minus root 3 to iota. So here your r will be equal to half square plus root 3 square. That will be 1 by 4 plus 3 by 4, 4 by 4. So your r is 1, and your cos theta, that will be 10 theta, that is minus root 3 by 2 by 1 by 2. So this comes out to be root 3, and this is equal to pi by 3, but pi by 3, x positive, y negative, it lies in the second quadrant, so your theta will be fourth quadrant. So your theta will be minus pi by 3. Because x positive, y negative, so your argument of z, that is theta, will be minus pi by 3. So here this gets converted into cos minus pi by 3, this will be pi by 3, and cos minus this will be minus I sin pi by 3 to the whole power 200, that is equal to p by 2 plus iota q by 2. So up till this this is up to your +2 level. Now the graduation level enters here, that is the de Moivre theorem. This power goes here, cos 200 pi by 3 minus I sin 200 pi by 3, that is equal to p by 2 plus I q by 2. This is the only level, graduation level. Now you can find out the value of 200 pi by 3. This will come out to be minus sine pi by 3, and this will come out to minus cos pi by 3. So this will be equal to p by 2 plus I q by 2. This is your class 11 level. You can find it out easily. So it comes out to be minus sine pi by 3, and this comes out to be minus cos pi by 3. So here your pi by 3, this is this comes out to be pi by 6. This comes out to be pi by 6. You can calculate it. You will come out. This will come out to be sine pi by 6. So the value of this is minus half, 6 means 30 degree, and this value is I root 3 by 2 sine 30 degree. You can calculate it and you will find out the value. It will come to be sine 30 degree. So the minus sign comes from the quadrant checking. So this will be equal to p by 2 plus equal to p I q by 2. Now further if you equate it, your p is equal to minus 1 and your q is equal to minus root 3. Now here these are the roots, you solve it. So this will be how much? P plus q square. So p value is minus 1 minus root 3 and q square, that will become out to be 3. So that is 2 minus root 3. And again p minus another root is q plus q square. So p value is minus 1 and this comes out to be root 3. So this will be again 3. So 2 plus root 3. So these are your alpha and beta. Now you have to find out the equation. So here your alpha plus beta, this will comes out to be 4, and your alpha into beta, that will come of 2 square minus root 3 square, 4 minus 3, that comes out to be 1. So your quadratic equation becomes minus 4x plus 1 equal to 0. So this is your answer. So you have seen it, only a line, which is the graduation level. This is the your graduation level. This is your graduation level. Graduation level, which is not included in your higher secondary level. So this is all about this question. Here let Z denotes the number, complex number, and let I, that means iota, that is equal to root minus 1. The number of distinct roots, this is 2022. So here you see that this question is not a tough question. Just let you take Z is equal to x plus iy, and you just put the values of here, put the values here. So this is x minus iy minus iy the whole square minus, I bring it here, I x minus iy and plus x plus iy the whole square is equal to 0. Because I have shifted this in towards your left side. So you have to just expand it, nothing, there is nothing here. Iy minus x square plus 2xyi minus y square and minus I, that is x minus iy, this is x square, uh, x square plus 2xy iota, that is I means iota, I square uh, is equal to 0. So here again your x minus iota y, x square minus 2xy iota plus y square minus, this will be iota into x minus minus plus I square, that means again iota square, that means again it will be minus 1i minus iota x square, and this will be again minus iota square, again minus 1. So this will be minus 2xy, and this will be how much? Plus iota y square equal to 0. Now what I am going to do here is that I am going to separate it, the real part and the imaginary part. So your real part is the x minus x square plus y square, again this is minus y minus 2xy. These are the real part, and your imaginary part, it is plus I minus y minus 2xy again then it is minus x square and plus y square equal to 0. Now because it is 0, so your real part is also 0. Plus y square minus y minus 2xy equal to 0, and your imaginary part is also 0. Minus y minus 2xy x minus x square plus y square is your 0. Now these are the two equations. You subtract it, 1 minus 2, 1 minus 2. What are you going to get? Here you see x minus x square plus y square minus y minus 2xy minus, when you substitute, this comes to be plus y plus 2xy, this comes to be plus x, this comes to be plus x square minus y square equal to 0. So now here you will see that your minus x square plus x square cancels out. Again y square, your minus y square cancels out. Again minus 2xy, this plus 2xy cancels out. So what does your minus y and plus y also cancels out. So what are you going to get here? Is there something mistake here? Plus y square minus y minus 2xy. This will be minus y minus plus y plus 2xy plus x plus x square minus y square. Here this is minus 2x, this, let me see here again, here this is x square plus 2xy, I square means iota square, that means minus 1, so it comes out to be this minus this plus, again here minus iota x, minus into minus plus I square means minus 1 minus y, this is minus iota x square, this is minus 2xy iota square, again minus 1, and this comes out to you to be plus y square, iota y square. So these are the two equations. So this minus this, it will be how much? It comes out to be here this minus this, so x minus x square plus y square minus plus y plus 2xy plus x square minus y square. So here your so here this cancels out, again your y square cancels out, so only remaining here is 2x is equal to 0, that means x is equal to 0. You are getting here x is equal to 0. Let me recheck it here again. It looks something wrong has happened here. Let me check it out. Here this will be minus iota x minus 1 plus iota square minus 1. Again here this will be this will come out to be how much? Um, uh, this minus, here you see minus and iota square plus, this will be plus. This is the mistake here. This will be the plus. So here this will be the plus. So here again your this will be the plus. So this does not cancels out. So this xy. So I was finding something because I got direct x is equal to 0. So this comes out to be x twice x plus 4xy equal to 0. So here your 2x common, your this will be 1 plus 2y equal to 0. So x is equal to 0 and y is equal to minus 1 by 2. So here there was a slight mistake here because I was finding it there is some mistake because I am getting on direct x is equal to 0. So this is not possible. So here this this was the mistake here because iota minus into plus minus and iota square, that is minus 1, so it will be plus. Now the next is that I am going to this 1 plus 2. What is the result I get from 1 plus 2? If I do 1 plus 2, then the 1 plus 2, this will be how much? X minus x square plus y square minus y plus 2xy. Again plus this one, that is minus y minus 2xy minus x square plus y square is equal to 0. If we add these two equations, so from here what do we get is that you see x cancels out, and again here only x cancels out, and this part it cancels out, this x cancels out, and rest there is, that means you are going to get minus 2x square plus 2y square and minus 2y equal to 0. So here you see that you are going to get minus 2x square plus 2y square minus 2y equal to 0. So since x is equal to 0, so you are going to get 2y square minus y is equal to 0. So here y minus 1 is equal to 0. So y is equal to 0 and y is equal to 1. So you are going to get 4 distinct values, 1, 2, 3, 4. You are going to get 4 distinct roots. You are going to get 4 distinct roots. So this was a simple question. Nothing but you have to just place the value of z, and it is 0. So your real part is 0, imaginary part of the is 0. You have got two equations. So first you subtract it, second time you add it, and you are going to get the roots of this equation. So there are 4 roots, 4 distinct roots. Now my next question is, this is 2023, is that here you see z, it's a complex number with a non-zero imaginary part. So here this is a real, this is real, a real number. See, this is a real number. The most important thing, this is a real number. For real number, z is equal to z bar. Z is equal to conjugate of that z. They are equal. This is the main concept of this problem to solve it. So first of all, what I am going to do is that divide it. 3z plus 4z square. I am going to divide it. 2 plus 3z plus 4z square. So here 1 times, that is 2 minus 3z plus 4z square. So this comes a minus plus minus 6z. So this comes out to be 1 plus 6z by 2 minus 3z plus 4z square. So here again 1 plus 6z, I am going to take z common to remove z from the numerator. 2 by z minus 3 plus 4z, this z common, this is 2 by z. This z cancel out. So because this is real, so this is real. So this is real. So here your z is equal to z bar. So that means 2 by z minus 3 plus 4z is equal to 2 by z bar, z bar minus 3 plus 4z bar. Now this 3 and this 3 cancels out. So 2 by z minus 2 by z bar is equal to 4z bar minus 4z. So here you will get that 2 z bar minus z by z into z bar, that is equal to 4 z bar minus z. So here you see that this and this cancels out 2 times. So 1 by z into z bar is equal to 2. So your z into z bar is equal to 1 by 2, and you know that z into z bar is modulus z the whole square 1 by 2. This you have to find it out, and this is your answer, 1 by 2. This is your answer. So this is a simple question. Only the concept lies is that when it is real, your z is equal to z bar.